I know you guys are dying for lunch. So the talk is No More Raw SQL, SQLAlchemy and ORMs. My name is Patel, and as he mentioned, I work at Bloomberg as a software engineer. This is my first time giving a proper talk. I've given a couple of tutorials, but it had way less people, and I was certainly not on a stage. So I'm excited to be here in front of you guys. And you can connect with me on LinkedIn with this URL, and you can do that stuff later. But what are we gonna talk about today? So the agenda for today is SQLAlchemy. I'm gonna give a bit of an introduction, some overview, and discuss some advantages. But the main bulk of this talk would be a journey with some examples. And the journey would be something like you start with a random service, microservice that we've designed, and on top of that, this journey will take you through multiple steps, and the service now uses raw SQL text. We'll add SQLAlchemy to this, then we'll add ORMs, and then finally we'll add some optimisations. So it's a step-by-step journey with some examples. Let's get started. What is SQLAlchemy? It's an open source SQL toolkit for Python, and this allows you to interact with your database in an object-oriented manner. So it's split into two main components called the core and the ORM, which stands for Object Relational Mapper. We'll discuss all of this in detail later during the talk. But in short, if I were to summarize my talk in 5 words, it means no more raw SQL queries. I'm sure you guys must have used SQL queries, and in production environment, you must have had multiple tables and hundreds of lines of confusing and bulky SQL code. Today, we're going to talk about how do we eliminate that. So this is an overview of the SQLAlchemy library. As I mentioned, it's split into two main components, the ORM and the core. Let's start by talking about the engine. The engine is part of the core, and it's the starting point of any SQLAlchemy application. And this is the place where we define the database name, the host and the port, the username, password, all the configuration of the database. And below we have the dialect, which is a Python object that allows us to talk to a particular kind of database with a particular DB API. So the dialect of MySQL would be different to a SQLite dialect, for example. Connection pooling maintains a pool of active database connections in memory, so it's easy for you to switch between different databases if you want to. And DB API is Python's low-level API, so it's not a part of SQLAlchemy, but SQLAlchemy uses DB API, and it's Python's low-level API, which is required to talk to a database. The SQL expression language is the main, the main core of the core, and this is the reason why we remove the raw SQL text, and we can build queries using SQL expression language. And this includes its own schema, its types, and keywords like select, join, filter, etc. I'll show some examples later. And on top of all this, the ORM builds upon a domain-centric view of the database, and we can interact with the database using an object-oriented manner. So the core is like a foundational architecture which will act as a database toolkit, and this will allow you to connect to a database, build your queries, and even insert some data, do all of that stuff, and the SQL statements would be constructed programmatically. The ORM will now provide object relational mapping capability. This is nothing but the tables of your database are your classes in Python, and your columns of the table are your class variables. This means that a row in your table would be represented as a Python object of that class. The SQL expression language is also used here along with the core. And once we do this, we can compose the query in terms of objects rather than raw text. So here's a simple example. So this is a query that I've created. We are selecting a bunch of data and joining 3 different tables, and we also have a bound parameter and a where clause. It might look simple right now, but this is a really simple example. Imagine you joining 10 tables and having views and whatnot. But let's see what SQLAlchemy does to this. Boom, the huge complicated query got converted into simple 2-line of code where we have a select orders. Orders is the ORM class, And then we have a .where parameter, which will select the orders of a particular customer. That's what this query is doing. SQLAlchemy supports almost all major databases, including PostgreSQL, SQLite, and Bloomberg's ComDB2 as well, which is a relational and distributed database system. Let's talk about a few advantages of it. First and foremost, this is my favorite one. There are no more raw and bulky SQL queries in your code. This is just a straightforward advantage. But as a bonus, it also prevents SQL injection attacks because it uses prepared statements. Now, if you were to migrate your database, it becomes much easier. And there's also a tool called Alembic, made by the same person and the same group of people who made SQLAlchemy, which help you do this. The core is separate from the ORM. So if you're not a fan of the core, if you're not a fan of the ORM, you can still use the core and all its expression languages and its connection pooling and whatnot. And there are different loading strategies to optimize your performance. You can configure which strategy suits your needs the best. It doesn't have to be one strategy fits all. Oops. It doesn't have to be one strategy fits all. I'll show some examples for this one as well. And since ORM are objects, it's easy to write tests and fixtures because you can mock those objects. Your testing framework becomes much easier. There's also an async IO extension, which I won't cover today because it's only half an hour talk. But we covered this in our tutorial previously, how we can use the asynchronous capabilities to asynchronously read our database. And this makes it much more efficient. And your life becomes much more easier. Trust me, I've been there. Okay, so let's start the journey now, as I talked about. So we have a sample marketplace application, and it's a Python microservice which uses MarketDB, which uses SQLite as a database, and the name is MarketDB. And the sample service is kind of like a marketplace with the point of view of a shop owner or store owner, where you can query get me the customers who've shopped over here, get me the orders of a particular customer, get me the total cost of a particular order, etc. So this is how we gonna see how SQLAlchemy affects this service. So we have 5 tables in our sample demo service, namely the customer, address, orders, order items, and item. And the columns marked in italics are the primary keys of those tables, and those are the column names in the gray boxes. And you might see there are some relationships between these tables. For example, the customer and address have a one-to-one relationship, and orders and order items have a one-to-many relationship. Order items acts like an association table, where if I were to insert a new order, there would be one entry created in the orders table. For example, the customer 5 has created a new order at this time, and then for each item the customer brought, there would be multiple rows in the order items table, where the order ID would be the order ID, and then the item ID would be the ID of the item the customer brought with the quantity. So this is how our database looks like, the MarketDB. Let's see how we query these, a few different examples. So traditionally, if we were to use no SQLAlchemy, no ORM, nothing, you would just have a raw SQL text called select star from customers to get all the customers, for example. And our query would look something like SQLite3.connect. As connection, we get the connection from SQLite3, which is a Python package for the SQLite database. We get the cursor from the connection, and we execute the raw SQL text on the cursor. And to fetch all the results, there is a .fetchAll method on the cursor, and then we return the rows. It's quite straightforward. This is how people do it, and everyone does it. And you would get a list of customers with their IDs and address IDs and whatnot. So this is how we do it without SQLAlchemy and without ORMs. Now, this is another example, but instead of just simple select star from customer, you have get total cost of an order, where we are selecting table and then we are joining some tables. And we also have a where clause, which will allow us to filter what order ID we want to get the total cost from. And the execute query function is still the same, and then the result would be something like order total and then the number. So this is raw SQL text. Adding a new order is also similar, where you have some SQL text to insert into orders, and then a function for execute insert query. This one again gets the connection from the SQLite 3, gets the cursor and calls execute, and then calls connection.commit to commit to the table. And similarly, to insert multiple rows in the order items table, we have another function called execute insert queries. And this one calls execute many because they are a list of parameters. This is how it's implemented, like anyone would implement using SQLite 3. Let's see how SQLAlchemy would do this. And let's do some alchemy. So as I mentioned, the engine is the entry point of any SQLAlchemy application. We first create the engine by calling create engine, which is imported from SQLAlchemy, and we pass in a connection string. So for SQLite, we have the SQLite, which is a dialect, and SQLAlchemy now knows that this is the SQLite dialect, which is used to communicate with this database. PySQLite is the DB API that we are mentioning. So a database can have multiple DB APIs. This is PySQLite, which I'm using here. And then finally, we have the database name. In PostgreSQL, for example, the string would be something like, that would include the host and the port, the username, password, etc. And finally, we have this echo equals true flag here, which will just log the SQL statements generated by SQLAlchemy. I'll show an example of this as well. So once we created the engine, we want to fetch the connection, and we can just do it by, like, first of all, connection is a unit of connectivity, which is a proxy object for the actual DB API connection that we used earlier. And this allows us to execute the SQL statements and also provides a way of controlling transactions. We're using context managers here because we don't want to keep the connection running indefinitely. So when we exit the context manager, it will automatically call connection.close at the end of that. So we don't run into like race conditions or something like that. So this is the example. It's quite straightforward. We use engine.connect, which will fetches the connection object. And with that, we can just call connection.execute and pass on the query inside it. This is how we get the connection from engine using SQLAlchemy. So let's see how we can execute select statements now. So I'm executing the same query, select star from customer. And this is the connection that I had shown you guys earlier. And this is what SQLAlchemy does in the background. So since we put echo equal to true, we can see what's running behind the scenes. The first statement is begin, which always runs for any SQLAlchemy application. And then we have, in the second line, we have the query that we had written, select star from customer, which is to get all the customers. And then the third line has empty parentheses because we are not passing on any parameters. And finally, we have a rollback. So rollback is logged at the end of every connection because we are not committing everything, number one, and we ensure we roll everything back to keep the connection clean for the next use. And we can also pass on bound parameters using the colon notation, where we can, so this example gives you like, we get data for a customer, for a particular customer ID, and we can pass in bound parameters and dictionaries. So SQLAlchemy can handle this as well. A warning, never put all these parameters directly into the string. For example, like don't use F strings or don't use like string concatenation for this, because you might be vulnerable to SQL injection attacks. If you do it like this, your application will be safe from this. Now, committing data. This is also provided by SQLAlchemy and is quite straightforward. And the way to do this is we first get the connection from the engine, and then we call the execute method in the connection. And we have to manually call connection.commit before we return the result or something like that, because we want to say that, okay, I've executed this query and I want to commit this series of operations into my database. And this is an example. I've used the same string, which is inserting into orders. And this is what happens behind the scenes, where you have a begin. Again, it happens every time. And then the next line shows you the SQL string generated by SQLAlchemy. And then in the third line now, we have a bound parameter, which is 1. We are inserting 1. And finally, instead of a rollback, we have a commit, because now we say that I want to commit this operation into a table. And this strategy is called the commit as you go strategy, because whenever we want to commit something, we manually have to call connection.commit. There's another strategy called begin once. Yep, this is a red circle if you guys hadn't seen it. There's another strategy called begin once, where we use engine.begin, where we don't need to manually say connection.commit every time. It will automatically invoke commit at the end of while exiting the context manager. And here you can see that commit was automatically logged. So we've seen how SQLAlchemy can improve our vanilla microservice. But let's add ORMs and let's make our life even more easier, because now we are still using raw SQL text. With ORMs, we will no longer need to. So declarative mapping is basically we are mapping the tables into classes, and the columns of the table become your class variables. So this is possible by creating an empty class called base, or you can name it whatever you want, which inherits declarative base. And I've just passed on nothing. I've just put pass here because we don't need to mention anything for this example. And whenever we want to create new ORM classes, they would need to inherit this base class. So map classes, for example, for the customer, the class inherits the base class that we defined in the previous slide. And the first attribute is the dunder table name class variable, where we can say the table name of this ORM. For example, here we have the customer class, the customer table for the customer class. And now we have 3 different columns in our table. So we'll have 3 different class variables, namely the ID, name, and the address ID. That's the name of the column name as well. So we have used the same name for the class variable and the column name. The type of the column name is inferred by the mapped annotation, which is derived from PEP 484, the type hinting PEP. And so if we pass an integer in mapped, it derives that this is the integer data type of the column. If we pass in string, it will know that it's a varchar. And this is how SQLAlchemy understands what is the column and what is the data type of this column. Now you might see that the ID column has 2 special attributes in the mapped column construct, namely the primary key and auto increment. Primary key just says that this is the primary key of this table, and we just say primary key equal to true for that ID class attribute. And auto increment is set to true because in our database we've set it up in such a manner where when we insert new rows, we don't need to pass on the ID. It just automatically increments by 1. So we just mark that for SQLAlchemy to understand as well. SQLAlchemy also implements a default dunder init method for ORMs. This will help us to instantiate objects by creating new instances of that class. Now, I talked about relationships in the diagram that I showed you guys earlier. The way to do that is to import this thing called relationship from SQLAlchemy.orm. So we create a new class variable called customer. So this is the ORM for the address table. And in the address table, we create a new attribute called customer because both have a relationship to each other. And instead of mapped of int or mapped of string, we pass in mapped of customer, which is the name of the customer ORM. And then we call the relationship construct. Here I've used lazy equal to joined. Don't worry about it. I'll talk about this in the last section. And we can do the same thing for the customer ORM as well. And address ID, we've modified address ID to include a foreign key, which is a special construct to signify that this is a foreign key to the ID column in the address table. That's a notation, table name dot column name. And with this, SQLAlchemy will understand how to link these two tables using the foreign keys in the ORM. Now, this is how it is when we see both the ORMs. And since it's a singular type in mapped, where I have mapped of customer and mapped of address in those two ORMs, it will infer that this is a one-to-one relationship. If we want to show one-to-many relationship, we need to put a non-singular type in the mapped construct, which is mapped of list of order items in the orders ORM. So with this, SQLAlchemy will understand it's a one-to-many relationship. Now, once we've set up the ORM, our life has become much more easier, and querying data is super easy now. So the session is the transactional interactive object for ORMs, and this is how we will interact with rather than connection, because session is almost identical to connection and also uses connection in the background. And sessions uses the commit as you go strategy, where we manually need to call .commit after every group of statements where we want to actually commit to the table. So here's an example. First, we get the session. We import the session from SQLAlchemy.orm. We pass on the engine to the session, so we know that this is the engine, or this is the database we want the session to be instantiated in. And then we create a statement. For example, I have created select customer, which is the same as select star from customer raw SQL query. Customer is the customer mapped class that we had defined earlier. And then we call execute on the session. And you might see there are two fields called on the result, .scalars and .all. .scalars does nothing but it gives us the actual ORM instead of the result, because result object might be like confusing, but when you use .scalars, you'll get the actual instance of the class in your response. And .all will give you all the results rather than just one or some. And since this is a query to get all the customers, I'm using .all at the end. And this is what your output would look like. As you can see, it's a list of customer objects in this because I've used .scalars, and you can see that there's customer, and you have the ID, the name, and the address ID mentioned here. And you also have the address information for this particular customer, because there was a relationship between those two classes, and you also have the address information attached to this customer. And this is what SQLAlchemy does in the background. First, you have the begin statement, which is implicit. Then you have the select query, which was automatically generated by SQLAlchemy. I had just put select customer, but this is what goes in the background. This is all the magic that SQLAlchemy does for you, where you have select some columns from customer, and then you have a left outer join automatically being generated. And finally, you have a rollback. So this is where the magic lies. You just say select customer, which was really intuitive and understandable in English, and then the complicated query is built in the background. This is an example of a little bit more complex query. This gets the total cost of an order, and instead of just select customer, you have select item.price times order items.quantity, and then you have .join attributes for the orders and the order items table, and finally you have a .where attribute to know which order ID we want to get the total cost from. And then I'm summing it up with Python sum the total. And this is the generated SQLAlchemy. This is the generated SQLAlchemy expression, where you have the joins and then you have the where clause. And in this one, we also have a bound parameter passed on, because we had passed in which order ID do we want to send to get the total cost. Finally, we have a rollback because we haven't committed anything. Now, inserting data is also super easy. You can do that by using the session object again, and you can just add those newly created objects to the session. So here is an example of me adding two objects to the session. So adding two objects to the table. So we have the order and order items table. So we first create an object for the orders where we pass in the customer ID and the date time, which is right now. And then since there was a relationship of order items on order, we just set a list of order items to the order items relationship. So we don't need to manually insert. So previously we had seen there were two different functions in execute and execute many, and we had different SQL strings for them. So we don't need to do all of that. Since there's a relationship between these two tables, you can just create objects and then link those link the list of those created objects to the relationship. And once you have your object ready, you can just add it to your session by using session.add. And right now it's still in pending stage, and we haven't inserted it to the database until we call session.commit. At this point, we have successfully inserted all of this data into a table. And this is the way how we insert things into a table using ORMs. This is what happens in the background. So you first have an insert query for the orders table with bound parameters. And then you have another insert query for the order items table with a list of bound parameters. So SQLAlchemy does all this for you. You don't need to have different functions for execute and execute many. And it's super easy and super readable because we are just using Python. We are creating objects of the class and then putting these objects into the session.add and then committing it. It's super intuitive, at least for me. So this is how we did. This is how ORMs helped us to help our life, but we still can optimize a little bit and talk about some optimisations. So I talked about different relationship loading strategies earlier. Let's talk about lazy loading. Lazy loading means you load the objects without loading the related objects initially. Say you have a parent and a child relationship where a parent has multiple children. So lazy loading means when you load the parent, you load the parent itself. You don't load the information of the children. And to load the information of the children, you have additional select statements for each and every child. And this is the default strategy of SQLAlchemy. If you don't pass on any parameter for lazy, it will use lazy loading. This is helpful when you are not going to use all the child objects and you're not gonna need them in your application, or you don't require them instantly. So you need it like in some other API call. So lazy loading is helpful in that case. So you can say lazy equal to select in your relationship, or you can just pass in nothing because it's a default. And to test this out, let's get the customer, and for each customer, let's print the address information. Let's see what SQLAlchemy does in the background. Now, the first query is a select query for the customer. So we select some information for the customer. Then we have a query to select the address information for the first customer. Then we have another SQL select query to load the address information of the second customer. And then we have one more to load the address information for the third customer. So as you can see, just to load some information, there were 4 select queries generated. What if we had 100 customers, or 1,000, or even 1,000,000 customers? What if we were so successful that a lot of customers were visiting our store? Would you generate like 1,000,000 queries just to load all this information for a customer? For all these customers? Sorry. No. And this problem is called the N+1 problem, where we have multiple select queries to load information of all these related objects, where we have one query to load the information for the parent. And then we have n queries to load the child information for n different children of the parent. This can be solved by using eagle loading that we had used in the examples earlier when we called lazy equal to joined, where this fixes the N+1 problem and all the related objects are loaded upfront. So the parent and the different children are loaded together when we use eagle loading. And this is achieved by using joins with the select statement, or like another additional select statements with the same query. And it's useful when you want to fetch all the information of the objects with the parent object at the same time. And this is what SQLAlchemy does in the background for you, where you select something and then it calls left outer join automatically. so we can join different tables and get all the related object front. Finally, one of the optimization is using SQL functions, where you could use aggregate function, for example, into our query, into our Pythonic query itself. Before I was using Python sum to sum the total cost of an order, but here I'm using func.sum to use SQLAlchemy sum. This helps your application improve your performance by a little bit. So finally, we have taken a raw SQL text with multiple joins and multiple joins on different tables and using parameters, and we've converted to using SQLAlchemy with ORMs, which is really understandable and almost intuitive, like you're coding in English. And this is maintainable, and it helps you in the long run, and it just makes our life easier. So I had given a workshop on this at a couple of conferences before. You can go to this link, and we have a lot of extensive documentation, and this also includes async IO, so you could just play around with this if you guys want later, which is much more detailed. It was like a 2 or 3 hour workshop, and that is very descriptive. And that's it. That's me. Thank you guys for being here and listening, and it was an honor talking to you guys. Thank you.